Hello everyone. Today we're going to start a multi-part series on building your own custom MobiFlight device. If you've built a few different MobiFlight cockpit controls by connecting some switches to an Arduino to add some realism to your home flight simulator, but you want to go beyond switches and 7-segment displays and aren't sure exactly how, this is a place for you. I've built a number of custom MobiFlight devices, including a feature-complete G5 HSI and PFD using a large color screen, and a CAP 140 autopilot that goes beyond the usual 2-row 16-character display. If you're familiar with Arduino programming, this is totally within your grasp. The MobiFlight custom device development process is fairly straightforward once you get your environment created and understand the right place to put your code. However, even getting to that point can be challenging. So I'm going to assume a few things for this tutorial. First, this is a 301 level course, and I assume that you've been using MobiFlight for a while and understand the fundamentals of how it works. Second, I'm assuming that you've programmed within the Arduino framework before. There are some conventions with Arduino that may not be obvious if you've never worked with them and are just familiar with C. And that brings up my third point, is that I'm assuming you're familiar with C, C++. I'm not going to teach you to code. You certainly don't want that. But I will be doing some coding in later tutorials, and we'll discuss some of the ways that the MobiFlight custom framework interacts with that. So with that as our baseline, I'll break this tutorial series into a few parts. Today we'll get your tool chain set up and your basic compile working. And then the next video will include a walkthrough of that custom firmware template and an explanation of how the custom devices interact with the MobiFlight client program. After that, we'll explore designing and planning your project, finding and connecting displays, configuring the MobiFlight client, and putting it all together. The custom project that I'm working on, or I'm about to start here, will be an engine monitor. It should work with any plane, even if it doesn't have a built-in engine monitor of its own. So we're going to be basing it on the Garmin GI 275 EIS, but for the first couple of videos, the actual project won't really matter. So let's get started by installing the software we're going to use to develop. We're starting from scratch here, and if you've only coded Arduino in the past using the Arduino IDE, today we're going to take it up a notch and we'll be moving to VS Code and PlatformIO. If you've already got those installed and are familiar with them and are comfortable moving around GitHub, you can probably jump right ahead, and we'll get on with it after that. But for those of you that are just graduating, so to speak, let's get started and let's install VS Code, Python, Git, and PlatformIO. That'll form the tool chain we need to compile the MobiFlight firmware for our custom device and give us a baseline to start developing from. I'll be using the pause button judiciously today because some of these installs can take a minute or two, but I will make sure all the links are in the description, and I'll point out anytime when I'm not taking the defaults. So let's get started by downloading VS Code and getting that installed. VS Code is a free IDE from Microsoft that you're able to develop in dozens of different languages, and it's got a rich ecosystem of, I'm going to change the defaults here by adding open with code in these. A rich ecosystem of plugins and add-ons, one of which is PlatformIO, which we'll be needing to do our Arduino development. VS Code sets up pretty quick here, and then we'll install a couple of different extensions to it right away, and then move on to the next things. While that's getting busy, let's we're also going to need Python, so let's do Python install, and we'll download Python. I'm working on Windows 11 here, if anybody's wondering, and I'm actually working in a virtual machine that has nothing installed, so we are starting from scratch on a lot of this. Okay, so we'll get VS Code. Here comes VS Code. And this is the main interface of VS Code. You've got an Explorer here where you'll find your project files, and what we'll look at right here too are some of the extensions that we're going to need. This bar right here brings up a lot of the extensions, or all the extensions, and we'll grab a few of them right off the bat here. So I'm going to grab this C++ one, and that's installing. My Python download is complete. You know what? Rather than jump around, why don't we just do these one at a time? My Python install is complete, and I'm sorry, my C++ is complete, and we will just close down Visual Studio for right now. Let's get Python installed, and we are going to override a few of the defaults. So we will take this first one with this long path names. And we'll take the default on this one. We don't need that. And we will take the default on that. We don't need the online help. So now we've got a working install of Python. We can confirm that that's in our, let's do Windows Terminal, WT. And we can do Python version. Oop. There we go. That's working. And we can make sure that code is installed properly too. And it's right there. Code dot starts up code with the directory that you're currently in. So we've got that working. Let's do Git next. Git is a version control. So let's do git install. And we will do that for Windows. There it is. We'll take the default install location, and we can take the defaults here. This one we will change. So we're going to change to Visual Studio as Git's default editor. We can let Git decide the branch name. That's if you don't like the word master as your Git default. We will take the command line and third-party software. We need that one. We can use the OpenSSH. We can use the Windows native. We can use the Windows style, Unix style. We will use Windows default console, so we'll change the default there. We can use fast forward or merge and their credential manager, and file system caching is fine with me. Now we'll go ahead. This should only take a second. This allows Visual Studio then to interact with Git from within Visual Studio, which is the way I like to do it. It also lets us use Git from the command line to pull the core repos that we're going to need to get going. When you're searching for your Git install, you do want this one, not the GitHub GUI user interface. I don't really care about the release notes, and so we'll just be done with that there. All right, so we've got that. The next thing we're going to do is add PlatformIO to our Visual Studio VS Code. So we'll start VS Code a different way here. We'll just come down here and do VS Code. We're going to start that. Come on. And as long as we're here, we come back to this a lot, so I like to pin this one to the taskbar. And let's go, we're going to go back to our extensions. We're going to add a couple more extensions here. What we want to do now is search for that PlatformIO extension. And there it is. The first one up, you're looking for this alien head, and you'll see that it has a ton of downloads, 6.1 million. So let's get that installed. We will trust them. And we'll get that one going. This one can take a minute or two, so I may use the pause button here. Okay, it's a couple minutes later, and PlatformIO has finished, and it's asking us to restart VS Code. A lot of times you don't need to do that, but if they ask me to, yeah, let's do it because it starts up pretty quickly. And there we are. We are back, and we have got our we've got a new icon over here, which is the PlatformIO head. From here, you can start creating new projects and setting up new projects. But what we're going to do is grab the MobiFlight custom firmware template from GitHub and use that as our starting point rather than just creating a new project from scratch. So let's shut this down. We're going to go back to our PowerShell window. You remember that I started this by doing command run WT. And what I'm going to do is just create a place for us to store our code. I am out of convention. I put all my stuff under a directory, under my home directory called, oops, haven't made it yet here though. Make dir source and cd into source. Man, you would think that I would be able to type. And now we're going to use that git that we did before to clone a repo. The repo that we're going to clone is the MobiFlight firmware custom template one. If we didn't have that handy, we could find it by MobiFlight custom firmware template, GitHub. This is probably overkill, but I'm hoping this will be the first one, and it is. So we'll grab that community template. If we go to that site, come on now. There it is. And we see this is the community template that is part of the official MobiFlight GitHub repo. And you'll see some instructions here. These are great ones to read. This is about all the documentation you're going to find is right in here. We'll be going through some of this, but for now, let's grab this repo. The way I like to do that is come down here, use the code button, and we will copy that URL to the clipboard. We're going to come over here and we use git clone and then paste that into here. So this is the URL to that repo. Hit enter. And that is going to, whoa. Oh, you know what happened? I did not restart this after we installed Git. And so Git is not in my path. So let's close this and let's start a new terminal with WT, cd back into our source directory. And now let's do that again. I used up arrow twice to get to that command. This time you see it finds it right away. The path gets set when you open up this PowerShell window. And since we had installed Git after I opened up this window, it wasn't in the path, and so it couldn't find Git. But now we're done. So if we take a look, we see there's a new directory. And if we cd into that, we will see that there's some new files, including the template and a few other files that we'll walk through in the next video. But for now, we've cd'd into that, and another way of starting code is I want to start VS Code in this directory. And what we will see happen here is now we see that same directory with those same files that we just saw over here in this terminal. We see those listed right here, and we can start working on our stuff. What's happening now, though, is PlatformIO is realizing that it is in the middle of a PlatformIO project, and it's installing a bunch of dependencies and pulling down some extra things that it's going to need to do to work. So let's do this full window, full screen. Just a quick tour. You've got a couple of different bars here in the Visual Studio while this is configuring. You've got a central area where you're doing most of your editing. You've got a left-hand bar that I usually use for my directory to bounce between the different files that I'm working on. But there are other tabs, essentially, or these accordion boxes down here that that you can also use, including one for the GitHub, which is very useful. This is still working by grabbing some different projects, and this is all just going on in the background. Just let it go. It'll take a couple minutes. And then finally, you've got a right bar over here that is often useful for AI agent, or You can also split this. I'll just open up another one. If you say open to the side, you can have two files open for editing at once. That can be super useful. We'll just close that down for now. We'll close up that. And what we're seeing is this PlatformIO.ini. And now we see that, okay, PlatformIO has done its job, and it has installed all its prerequisites that it needs. And it's through loading up, because I can tell because there are a few extra icons down here at the bottom. The key ones, you'll get to know all of these, but some of the key ones here are this is the build. It just does a compile and does all the checking and compiling and linking. It doesn't actually move the code to your device. This one does the same, but then uploads it as well. So it'll push it to your device if your device is connected. This one is very useful. It opens up a serial monitor that you'll often use for debugging your device. This opens up a new terminal so that you don't have to Alt-Tab over to that Windows terminal if you need to run some quick commands. This button changes the serial port that you happen to be working on when you have multiple devices connected. Auto usually works pretty well, but if you've got a couple plugged in at once, it won't always pick the right one. You click on this and then come up here to pick the one that you need. That's a good tour for now. I think we'll do one more task here before we take a break, and that is we're going to compile this for the first time. We've got the template actually compiles and will build. And as part of that compile, it is going to bring in the core MobiFlight framework. This template device, and this is where all your custom code is going to go, has the classes and the files that you'll need to be working on, but it also relies on that core MobiFlight capabilities that you use to do buttons or encoders or 7-segment displays, so that you can use those in conjunction with your final device. So for example, my G5, do I still have that open over here? Yeah. Or for this Cap 140, it has a number of buttons. These buttons aren't really part of my custom device. The only part that's my custom device is this display. These other buttons and rotary encoders just function as normal MobiFlight devices. And as part of the very first compile, it's going to pull in all the other repos that are necessary to build that one. So I'm going to do a PlatformIO build here, and you will see, oh, this is the fourth part of the Visual Studio interface. These terminals down here, you've got the output from debugs, you've got compile or debug errors and warnings will appear in these different tabs. And when you open up a terminal, a serial monitor, that will also appear in this area. This first compile takes a real long time. It is doing a ton of work. It's going to take 8 or 9 minutes for this to complete. So I'm going to pause the video here, let this complete, and then come back. We'll preview what we're gonna, and I think we'll take a break for the day. So you can take a note of the time down here and see when we come back. I'll try to come back shortly after it completes. Okay, and we're back. That took about 7-8 minutes there. We can see the total time here. I'm realizing now that you can't see my toolbar with my Visual Studio icon and the clock on there. But regardless, that did take a while. It took 427 seconds. Subsequent compiles will be very quick. Comparatively. This one had to pull down a bunch of libraries. It was compiling for the first time for a large number of platforms. And in general, once you get going, a compile or a recompile, an incremental compile as they call it, usually takes about 30 seconds, including the upload to the device. We didn't even upload to devices here, which would have added another minute or two for all these devices. But what came out of this was firmware that you could push to a Mega, to a Arduino Micro, to an Uno, to a Nano, or to a Raspberry Pi Pico, an RP2040. All of those were built, all of the code came in, all the libraries were downloaded, and that's why it took so long. So I think we're at about 20 minutes here. I think that's a great place to stop for the day. The next thing that we will do is start looking at this. If you're interested in looking right away, what you want to do is kind of examine these files, this MobiFlight custom device, customdevice.h, and especially my custom class and my custom class.h, which is where our code is going to be going. In the next tutorial, we will be setting up our custom code. We'll be getting going, and we'll talk about some of the hardware and design considerations for building your first MobiFlight custom control. Thanks.